Hello, everyone. That was an excellent introduction, so I probably won't add much other than to say that I do a lot of work with AI these days, and that comes in the form of doing things like deploying applications. So, like dymaptic has a couple of production AI applications, as well as powering AI applications for clients. So, we do this every day. And it is as strange and as new as this technology it is becoming a thing that gets used every day. And my very silly example is my screen back here, which you won't be able to see the whole time, but we'll check on it periodically. My screen back here is a thing I call the whisper frame, which listens to my presentations like this and it draws art about what we're talking about. So it will probably draw some interesting things throughout, but it's often hard to see on streams like this. So what I want to do today is kind of walk through how we can use AI to do data extraction. And in this specific case, we're going to put some constraints on what we're trying to do. So one, what we're looking for are parking lots. And this came from a meeting I had with several of the board members. And one of the things that was kind of a through line is using AI to extract data. And I think that parking lots was one of the ideas that came up there. And this is going to be a challenging one because there are a lot of parking lots, and the AI tends to get overwhelmed when there are a lot of options, especially confusing ones like parking lots and roads look very similar in aerial imagery. Even though as a human, we might easily know the difference in most cases. So I have not done anything other than prepare a few prompts to make this go just a hair faster. So I'm going to share my desktop here and we're just going to dive in. Windows. All right. So what I have here is Claude Code, which is a coding tool that I use basically all the time in order to build things. And back here, I have ArcGIS Pro, and we're zoomed into the Memphis area here. And if we just zoom in to an area that's kind of near downtown-ish, we can see that there's buildings. We can see buildings here, different types. We can see a lot of parking lots. We can see things that might be borderline as to whether or not they're parking lots, but we can definitely see different things here. And so what we want to do is we're going to use Claude here to write us a Python script. And you don't need to know Python to do most of what we're going to do today. I'm just going to ask it to build one. So the first prompt that we're going to use here is this, and I'm going to read it to you after I get it started. So what this prompt says is build me a Python script that takes an aerial image and uses the Claude API to detect parking lots. I want, oops, excuse me, let me give it permission to continue. Let's see, where was I? I want bounding box coordinates back as JSON, use Claude's vision plus structured output in a single API call. Overlay a faint coordinate grid, lines at every 10% with labels on the image first so that the model has reference point for accurate coordinates. Use CV2 to draw the detected boxes on the image and save the result. Okay, so that was kind of a lot, and there is some technical things in here that are important. And there probably are things, if you're not used to writing in Python every day, there are probably things in this prompt that don't make sense. But basically what we're saying is what we want to do is we want it to detect parking lots, and I want it to extract that data back in a structured format so that we can draw it on the image. Okay. And we'll get to run it here in a second because this Claude Code that's running here is working in this folder. So you can see it's just now starting to write this detect parking lot script, and you can see that I have a screenshot of the image in ArcGIS Pro. And this is just a screenshot. There's nothing fancy here. I just used the snip tool to take a screenshot of it. So it's not even a very good image. Okay, so over here, we can see it's finished and it's given me some output here and some additional instructions. Make sure that the Anthropic API key is set in your environment and use Sonnet 4.6 for cost efficiency in the visual task. Change to 4.6 if you want maximum accuracy. Okay, so a couple of things going on here. So one, we're using the Anthropic API. And so that means that I have to have an API key because I have to pay for it. And I'm going to pay for it by token, the number of words that are consumed. An image is also worth words, right? An image is worth 1,000, pictures worth 1,000 words. And so it's all consumed by that. So we do pay per token. So the more requests we send, the more we pay. And then we also have the option of using there's really three model types. There's Haiku, Sonnet, and Opus, because Anthropic thought they were cute and so named them after different types of writing. Haiku being smallest and least smart. Sonnet is kind of average intelligence, and Opus is the big deep thinker. And so it's basically telling us that we have to be configured to use this. So I'm just going to tell it that we have a screenshot.png file, run the script on that. Because I don't really want to even try to figure out how to run this Python script. I would prefer that Claude just runs it for me. So we're gonna just pass that screenshot off to it and see if it works. And of course it doesn't. So this is kind of one of the exciting things about this is Claude is actually going to go try to figure out why this didn't work, and it's going to try to fix it. And so the interesting thing here is the problem is just an SDK versioning problem, which if you've ever written code before, you know is a disaster, right? Keeping track of which SDK and which Python blah, blah, blah you're supposed to use is a hot mess, to say the least. So Claude's just going to fix that for us. I'm not even going to worry about it. We're just going to let Claude go ahead and fix that. And the one thing I will add here is what I did do in preparation for this is inside our project in ArcGIS Pro, we can go to our package manager and I have a clone of the original Python environment that comes with ArcGIS Pro so that I can install additional packages. And this environment, I always point to things like you can see me, but anyway, this Python environment here is the same one that Claude Code is using. And that's on purpose because in a minute here, when it gets through this part, we're going to have it build a toolbox tool for us so that we can actually get into Pro and start testing this process here. So let's see. So it looks like it worked. So let's go look at our files here. Yep. Okay. So remember, this was our original one, and here's our detected one. So what we want to do is we want to see kind of, this is the very first version of this, right? We're 12 minutes in here. Do we think this is going to work? The answer is a qualified maybe, right? So if I look at this, I definitely see things that like there's definitely a parking lot down here. This not a parking lot, right? This little clover leaf on the highway, not a parking lot. There's some over here. It kind of grouped a bunch together. But I think generally speaking, yes, it was able to help us identify parking lots. We're going to need to tune this a little bit though. What I don't know is I don't know if we're going to be able to get rid of the false positives here. So this bit here where it's identified that there's a loop in the highway here, I don't know if we're going to be able to get rid of that. And the reason is that and when you zoom in on this, that looks a lot like that, right? So there's a parking lot it didn't identify. There's a highway that it did identify. There's some parking lots that it did identify. So there's a lot, like roads look like parking lots in aerial imagery. So there's some things we can try here. We can try different resolutions, we can try different zoom levels, and then we can try refining the prompt to see what we can do. Okay. So what I want to do now, though, is I want to be able to run this in ArcGIS Pro. And instead of this, like this is just an image, right? These are not features or anything. It just drew colored boxes on the image. I want features back, right? I want like a feature class with this information. So this is the only other thing that I have pre-canned is I wrote out a description of a toolbox tool. And it's basically now I want you to build an ArcGIS Pro toolbox tool called AI feature detection. And then I'm giving it a list of things that I want it to do, and I'm telling it what the parameters are. And it kind of hides it here when I paste it in, but you can see it. I'm going to read it here. So what I want it to do is I want to get the active map view and its geographic extent using arcpy.mp. So what I'm asking it to do is I want it to basically take a screenshot of this view right here. So instead of trying to extract the original image source, I'm just going to take a screenshot of whatever is here. So that has pros and cons, but that's what we want it to do. We want to add our grid overlay. Oh, which I forgot to explain. I'll come back to that in a second. And then we're going to send that off to the AI for processing. And when we get back all of our little boxes, we get these boxes back. We want to convert those back from image coordinates into real world coordinates and create a polygon feature class. Okay, so that's what I've asked Claude to do. Let me have it work on that. So it's looking, so now Claude is off looking in our folder here, and it's looking to see if there are already files that maybe it should be using. And there aren't, so it's going to start a new one. And hopefully this works. I am not 100% sure what it's going to do here. But the other part that is important here is we're using a special technique where we grid an image. So probably at least some of you on the call have done heads-up digitizing before, where you have to open up ArcMap or Pro. For me, it was ArcMap. This is one of my first jobs, was doing heads-up digitization. And you open up, then it was like ArcMap 8. And you start, you go and you do edit and you click on the feature and you start drawing polygons and start filling out attributes, right? At least for parking lots. And when we're doing that, we can kind of zoom in and out. We can get higher resolution or lower resolution. We can just zoom in a little bit here and look at these different parking lots. We can get better imagery as we zoom in, because we're getting like that tiled imagery, and like this is actually pretty good, right? Probably if we were zoomed in this well, Claude would be able to identify that as an image, but we can't give it all of the raw imagery. We'd just burn all of our tokens, and it wouldn't be able to handle an image that large anyway. So we have to use different techniques. The first technique we use, and I should have had Claude show us this before it went off and built this, but it's going pretty quick, so maybe we'll have it go back. The first technique that we're using is it draws a grid on the image. So it draws a very faint grid over the image, and then it sends that to Claude. And the reason that helps is when it's zoomed in looking at a bit of an image, which to it will look something more like this, right? Because it'll get blurry as it zooms in. But when it's zoomed in, it has these reference lines that it can see, kind of like latitude and longitude lines, right? We don't actually tell it what like real world coordinates those are. We just tell it that those lines are at like 10% of the image. So we go 10%, 20%, 30%, 40%, et cetera, down the image so that it has these references to go by. And I know that sounds kind of weird, but when we're talking about an AI like this, we're really talking about a computer that's trained on human experiences, right? Human text. And so giving it references just like you would a human if we were trying to identify where a parking lot was in an image like this, right? You could say like, oh, well, it's like kind of in the middle. But up here, like describing where that is a little bit harder. But if we had a grid of lines on here and I could say, oh, it's in the fourth grid on the top, fourth one from the left on the top, then you'd be able to kind of identify which parking lot I was talking about. And so that type of information really can help the AI understand what's going on. Okay, so Claude has finished our PYT file here. So we're going to go add it to Pro. And we could go look at this source code, but I'm actively not going to because it mostly understands what's happening here. So we're going to go here and we're going to say add a folder connection. And I'm going to go to where I have parking lots. There we go. Parking lots. Add that. And in parking lots, there we go. So we've got our PYT file here. Yes, I want to allow this to run. Okay, so detect features. So here is our toolbox tool. So the first thing we need to provide it is our Anthropic API key, which I have over here in my secure password vault that you can't see on the screen. Okay, there we go. So I'm just going to paste that in here. And you notice that Claude was actually smart enough to realize that this is an API key. We want to hide it. So it used a hidden text input, which is kind of a nice feature. Okay, so now we're going to give it a prompt. Detect all parking lots in this aerial image and spit it out as detect features. Sure. So now what it's going to do is it's going to take a screenshot of this. It's going to draw grid lines on it. It's going to send it off to Claude, and it's going to come back with a bunch of locations in the image. And then it's going to take those locations and it's going to convert them to real world coordinates. And it's going to put them on the map here. Hopefully, that's what. Oh, okay. There we go. So let's make this so we can see it a little better. I can already tell the thing that we're going to do most frequently in this demo is change symbology. Okay, there we go. Okay, so it drew some boxes. This is actually maybe my favorite one. This one actually is right here. It labeled it as confidence high parking lot. It caught this one here in the middle, which is that's also a pretty good one. Then there's one like this, which I don't know. There's not really. That looks like buildings more than it looks like parking lots to me. Yeah, I don't. That's not great. This is kind of a mixture. This is kind of a mixture. Yeah, and then of course we got our one here that just picked up the highway, and this one here is kind of like that too. It read the highway as a parking lot. Okay, so there's a couple of things we can do from here to try to make this better. One thing that we can do, and this is going to seem silly, but let's take a screenshot of this. And I'm going to ask Claude what it thinks we should do. So we're going to go, we're going to go over here and we're going to say, this is kind of working, but as you can see in the image, there are several false positives. Brainstorm 3 ideas that we could use to make this process better. And then we do Alt V to paste the image in, I think. Yep, there it goes. So we can see the image got pasted in, and we send that off to Claude. And while Claude's working, I'm going to sit here, I'm going to think about what we should do instead also. So if we come back and we look at this, one thing that we could do is our prompt here was very, very simple. Detect all parking lots in this aerial image. Um, so we could try to make that better, right? If we were like an if I was trying to describe this to an analyst that I wanted to delineate this, like parking lots are maybe kind of trivial, but if I was trying to identify like a certain type of land cover or a certain tree or a certain habitat that I wanted to extract, I would describe this in different ways to the analyst, to the human that could do this work, right? And so I might do something like, pay close attention to dark colored parking lots, avoid building tops, and focus on, oh, well, let's see, avoid building tops and ignore roads. Sure. Okay, so just for kicks, we're going to call that 1 so we can compare our results and turn that one off. We're going to run that again. So we're going to let that run. And so this like crafting a prompt like this can be actually quite challenging. So one thing that we can do is we can actually use Claude to help us craft a prompt. And that is kind of a superpower of all AIs in general, because the AI labs, so like Anthropic, OpenAI, Google, et cetera, they actually will use models to prompt their own models. And so they will train into the model the ability and all of the kind of like functions and special capabilities of an image, or of an image of, got images on the brain, of the model. So the model is actually really good at prompting itself. So we can actually use Claude to make that better. But before we do that, let's just take a quick look at this. And I was right. Here we are again. I wish there was a way to make this. I wonder if there's a way to make the default symbology in Pro. I don't use Pro very much anymore. That probably is, you can probably tell that by now. Green, that was a terrible choice in color, Christopher. Okay. That's a little better. Okay. So actually, I would say this is an improvement over the previous one. If we turn the previous one back on for a second, I would say kind of generally, well, it's an improvement in some ways and not in others. So it got ones that we didn't get before, like up here at the top. It got different roadways, which is an interesting problem. And it still kind of got buildings here in the middle. So we would probably want to refine that even more. But let's see if Claude came up with anything while we were busy. So the first thing it came up with is a 2-pass verify and refine pipeline. So instead of trusting a single call, crop each detected bounding box from the original image and send it back to Claude as a second pass. Okay, that would be especially useful if we could get a higher resolution image, right? That might be a little bit complicated for trying to get done here, but that is a good idea, I think. So doing a second pass will help us prevent false positives. So that's going to prevent things like this building. Probably it's going to get rid of that, and the roadways, it's going to get rid of that. But it's not going to find parking lots that we missed in the first pass. So that's kind of a partial fix. It will also increase the number of tokens, so it'll increase the cost. Second one, tile the imagery and merge. So instead of one big shot, use a handful. So split the image into overlapping tiles and send each one separately. That also could be a good idea. So we're going to get smaller images, but we're not getting a better resolution in that case. It's just we're more in a more focused area, so the AI will get less distracted. And then prompt engineering. So that's kind of what we started to do. That's what I was talking about with you. We could use Claude to do that. And we could also, this is also a good idea. We could use few shot examples. So this is, that's a technique where we give Claude example data that is high quality in order to control its judgment a little bit better. So I kind of like this idea. Actually, I let's just try this because this prompt that it kind of cooked up here. Parking lot must show regular grid of rows of parked cars. Like this is actually a pretty good prompt. So I'm gonna copy that and let's just try that again in our geoprocessor over here. Let's just try that. We're gonna call that 2. I'm gonna turn this off because remember we're taking a screenshot. I don't want those boxes in there. So we're gonna try that again. So same exact process here. We're just refining the prompt a little bit more. And the other thing we could do is we could come over to Claude and we could say something like, you are an image specialist that is experienced in using GIS tools to extract data from imagery. How would you prompt a Claude instance to extract parking lots from an image with high accuracy? I don't know what that's going to do. We'll try that. I actually have a whole other process that we're going to try for that too, if we have time here. Okay, so bad news is that didn't work. Dropping out of range detect. What on earth does that mean? Why can't I make that bigger? Okay, you know what? We're going to copy this and we're going to go over to Claude and we're going to say, I was trying a better prompt and I got this error in Arc Pro. Can you see if you can fix that before we try anything else? And I'm just going to paste that in and press enter. Yeah, I'm not sure. Oh, okay. So the tool ran, but it detected things that were out of bounds. So um, when we're the technique that it apparently has used, and this is a legitimate technique. We can see here it dropped 8 detections because their coordinates were outside 0 to 100. So what it's doing is it's saying the image, like the left side of the image is 0 and it goes all the way across to 100. So it's like percentages, right? So it doesn't have to gauge the actual number of pixels. It's just saying, oh, it's roughly 22%. And so that's actually a pretty good technique for large language models because they can't see they don't see pixels the way we see pixels. What they see is tokens or equivalents of the image. That's also why cutting it up can help as well. Okay, so let's see here. So scroll all the way down to the bottom. Oh, yes, I do want you to proceed. So that's one thing about Claude Code is it, especially when working with ArcGIS Pro and building toolboxes, and this applies generically no matter what kind of toolbox you're building with Pro, it will ask you permissions a lot because it's trying to do things that aren't necessarily standard Python practice, right? It's trying to compile this PYT, which is an Esri file, not a regular Python file, but it's trying to make sure it's correct. So it will ask you permissions for all of those kinds of things. And it's worth just making sure that you see it's like, oh yeah, this is just compiling it. If it's like, oh, I'm deleting all of the files on your C drive, probably don't say yes. But it doesn't do that very often. Actually, I've never had that happen in Claude Code, only with unrestricted tools. Okay, so 2 fixes applied, stronger system prompt and clamp instead of drop. Okay, well, let's see if this works. I'm going to recopy this prompt here. Oops. recopy that, come back, and we're going to refresh this thing. Since we changed its code, we want it to reread it. I come back in here, paste that in. Oh, and I messed up my API key, so we'll drop that in. And detect features 3. That sounds good. Okay, so we'll run that and see if this works any better. Trying to decide what else we should try here. I think what I want to do is actually try a. No, it dropped some again. It's not super happy with this output here. This is what happens when you do things live. Sometimes it doesn't work. Those are not bad. We missed a lot, but this is also like, if we were doing swimming pools, it would probably be way more accurate. And the reason is there are just fewer of them. We could also try zooming in. Esri actually has a special tool that you can use to pre-process imagery into a bunch of slightly overlapping squares. So you could generate a whole bunch of squares of slightly overlapping images and then send each one off to Claude with its bounding box and get the results back. And so there's a lot of things that we could experiment with here to see if it would work better. But I want to actually try something different. I think what I want to do here, I'm gonna bring up a different thing here. Give me 1 second to bring up an empty one. Okay. So I'm gonna switch my screen share here for just 1 minute. We'll come back to Pro in a second here. Yeah, so here's my, there we go. Okay, so this is a different model. So you might have heard of this model. It's called Nano Banana. And Nano Banana is a very silly name, first of all. But what it is it's Google's image generation tool. And so you can see a couple of examples here, an icon representing a cute three-toed sloth. So you can see it can generate a wide variety of images. One of the other interesting side effects of Nano Banana 2 is that it can take images in and edit them. So, like for example, I used this to stitch together. I took 3 selfies of myself at the Esri Dev Summit a couple of weeks ago with people in the background, and I wanted to post it on LinkedIn, but I wanted to stitch it together. And so I used Nano Banana to kind of stitch it together. And it's not perfect. It's kind of weird, and my arm is super long, but like it was able to stitch basically 3 separate images together with just a little bit of overlap and me in all 3 of them, and still keep it so it looked like me. So it has a high ability to do image editing. And I've done things like this before with Nano Banana, where I've done swimming pools. So what I'm going to do here is I'm going to take a quick screenshot of that image that we were using in Pro. And I know you can't see that, so I'll be right back. So I'm going to paste that here so you can see that image. That's just that screenshot there. And I'm going to say, draw a red line around each parking lot in this image. And so what if this works, what this model should do is it should edit the image, adding a red line around each parking lot. And if that's the case, if this works for parking lots, then we can go back and we can ask Claude to build us a toolbox tool that can do this and return it as features. So let's see. That is actually fascinatingly good. It definitely, there's some weird business here. And there's some weird business down here that I don't know if you can see that. There's little tiny red boxes. Those are probably cars. There's some weird business going on, but it did not get distracted by the roads. It drew really nice, tight polygons. So kind of think this is going to work. Okay, so I have a Gemini API key. It's already loaded on this computer. So let's see if we can get Claude to do this. Okay, so I didn't prepare a prompt for this, right? So uh, you get to see kind of how gnarly these prompts can be. So I think what I want to do is, let's see, let's build a new toolbox tool that uses the Google Gemini Nano Banana API. And that has a real name. What is this thing's real name? It's Gemini 3.1 Flash Image Preview. The official name is Gemini 3.1 Flash Image Preview. Use that model to upload an image just like we were doing, but it should draw a red line around each parking lot. Then you can use image processing to extract those red lines into polygons and return that as a feature class, just like before. Okay, so make a quick plan and ask any clarifying questions. So that's kind of a thing that I always add to the end when I'm being vague and I haven't had time to think about this. But one of the really interesting things that you can do with large language models just in general is you can ask it to make a plan for itself. Oh, I'm sharing the wrong screen. I'm sorry. My bad. Let me bring that back. Windows. Okay, sorry. So you missed me typing that in, but here we go. There's what I was mumbling out loud when I typed that in. So I do have an API key, Banana API. I'm not familiar with that. Image generation approach. The model, should I assume this works like Gemini's image generation when you send an image in a text prompt? Yes. And same toolbox or new one. I guess it can be a new one. So rough plan, export and grid. I don't think we want the grid. So we'll tell it no grid. Step 2, Gemini API call. Step 3, redline extraction. Step 4, pixel coordinates to map coordinates. Step 5, feature class. Main risk is step 3, contour extraction without CV2 is doable, but rougher. I think we can use CV2. Okay. So let's see, what did I say? We were going to say no need to draw the grid. I think it is okay to use CV2. Pro is using the same Python environment as you are currently using now. I do have an API key. I do have an API key, and it should be just like the standard Gemini image model API thing, but you can also look up the documentation. Okay, so I want to make sure there's a time for a little bit of questions at the end. So we're going to let that cook for a second. And so one of the things that I didn't mention at the beginning is that there's more than one way that you can solve this kind of problem in ArcGIS. So the default way would be to go to the Living Atlas and download a pre-trained model. Unfortunately, I don't think that there is a pre-trained model for parking lots. At least there wasn't when I looked at this several weeks ago. So that's the first problem, is there might not be a model that can do what I need. All right, just granting permissions to a lot of things that it does research. Um, there might not be a model that works. And in order to run that model, I'm going to need a computer with a good GPU, not just like the minimum GPU that Pro would need, but I need something really powerful. So it's not going to run on my slightly aging Windows laptop here. Uh, I would have to go and rent something in the cloud, which I can do, but they are fairly expensive. We're talking about dollars an hour and not cents per hour. Medium.com. Sure, I don't know, whatever. Um, so uh, so that would be kind of the default way that we would normally do this in ArcGIS Pros. We would use those deep learning packages, and those can be neural networks, or they can be kind of traditional machine learning, like random forests and things like that we've done in the past. But the problem with those are, one, you got to have hardware to run it, and two, there might not be a model that works for you, and three, the model that does work for you might not work on your imagery, because those models are trained on a very specific set of imagery. And if you change the imagery type, even if it's the same like number of pixels or resolution, it might not translate correctly. And so you have to do what's called fine tuning. So you have to take your imagery and you have to reprocess that model with some output data. So you'd have to manually go and extract parking lots in our case and fine tune a model. So you'd want to start with a model that looked like it probably knew what parking lots already look like, maybe something that could do roads, and then fine tune it on parking lots with your own imagery on a big machine, and then run it to see how it performs. And so if you want to do something with super high accuracy, for example, if you're trying to do something like extract building footprints, or anything where it really matters, like if you're using it to enforce taxes or do something like that, where you want high accuracy and repeatability, then you want to use one of those kinds of models. You want to spend the time it takes to generate those models and test them and verify them and make sure that they are what you want, so that they will generate repeatable output for you. But in cases where you need to quickly extract information, or the accuracy of the information isn't as important, you can use large language models, which is what we're doing here. And the kind of really good example of this use case is aging now by a couple of years, but back, or by at least a year, when there were all those fires in California, they had live drone imagery showing houses that were destroyed. And what they wanted to do was very quickly categorize the house as like from 0% destroyed to 100% destroyed. And they could clip the imagery out using parcels. So you get a nice chunk of imagery. You can send that off to any of these large language models, and you're not asking it to extract, you're asking it to analyze. So different concept. So instead of trying to draw polygons, you're just trying to say for this image of a house, what percentage destroyed is it? And so you can do that type of analysis very quickly using these models. And it's actually much better at this than doing extraction like this. Okay, so it thinks that it's done. Let's go and give this a try. So I'm going to just refresh this whole folder. Yes. Okay, so detect features Gemini. Okay, so we need a Gemini API key. So we'll go grab that. Paste that in. Copy. Paste. There we go. Okay. And then it gave us a prompt to draw a solid red line around every parking lot in the aerial imagery. Do not add any other annotations, labels, or changes. Sure. I don't know. We'll take the defaults. I want to save time for a little bit of questions at the end for kind of how you do this. This has been a little bit of a whirlwind because I wasn't sure how this was going to go. And it is like kind of detecting parking lots, but I will say it's not It's not what I had hoped for. I had hoped it was going to be way more accurate than this. Excuse me. Doing in my experience, doing things like manhole covers, swimming pools, things like that, it's actually quite accurate at, even when zoomed out pretty far. Uh-oh, did not work. I'm just gonna copy this and say we got an error. Whoa, error running this in Pro. That's was my API key. Awesome. I'm gonna have to void that now because that's in the recording. Copy. There we go. Okay. So we'll let Claude chew on that. We got 10 minutes. So we'll let Claude chew on that. I guess are there questions from anybody while we let Claude chew on that? Make this Zoom thing a little bigger and see if there's any chat questions here. Okay, so no questions at the moment, but if anybody's got questions, please say so, and we'll try to answer those while we wait for Claude to finish this. Okay, so it thinks it worked. So let's just go try that again. Yes. Okay, so I gotta go get my now public API key and run that. Okay. Well, I might not use this. We'll see how this works. I might not use this to extract parking lots, but ooh, those are not parking lots. Oh boy. Okay. Well, we're just gonna make Claude go work on this. Okay. Well, these are not parking lots. Okay. So we'll let it think about what it's done for a minute here. But so I guess the short answer is I probably would not use this technique in the future if I wanted parking lots. Yeah, those shapes look like it's picking up building shadows. What? I don't know. Is that actually gonna work? Whoop.
Well, Christopher, we set you up with a pretty tough task here.
Oh, okay. Well, yeah, you did give me a pretty tough task. It is not cooperating. That is for sure. I'm gonna just copy this and give this to Claude here. This is the intermediate output that Gemini returned. There are definitely uh, parking lots here. It is not exclusively parking lots, but there are parking lots. Yeah, there are parking lots. Okay. What? Okay, I think it's confused because I think yeah. Um, I think about that. What to do here? Well, anyway, I guess we're about out of time. Let's see if there's any questions here. Could you upload Python script into Claude and have could you upload a Python 2 script into Claude and have Claude autocorrect or assist in updating the Python script for Python 3? Yes, totally. It's quite good at that. It's also good at like upgrading from a old version, like if you're moving from ArcMap to Pro, it's actually pretty good at that also. Um, but I would use Claude Code to do that, not Claude like the desktop app like this. Uh, Claude Code can do more research. It can do more things in the background. So you can say things like, oh, I want you to migrate this from Python 2 to Python 3 and maintain ArcGIS Pro compatibility, blah, blah, blah. You can give it some guidelines. And I think the main thing to think about when you're doing that is what would you give, uh, how would you describe it to a human? Um, and I think that's really the trick is describe it to that to the AI the same way you would describe it to a human. But hopefully, even though we did not extract parking lots very well, hopefully you all get the idea that building something like a Python script from using Claude like this actually works really well, and building toolbox tools work really well. Like it totally was able to build this geoprocessing tool for me quite like these all worked on the first try. I was not even sure that was going to work every time, but the toolboxes always ran, like the inputs worked and stuff like that. So all that like boilerplate that you always deal with as when you're building that, it didn't work or worked just fine. It's just the complexity of the image extraction. So I think the problem is in the conversion from the red polygon outlines to the features because they don't match. Let's see if it can fix it here in the next 5 minutes. But yeah, a little disappointed in its capability to do parking lots here. I really thought this was going to work better. But uh, I didn't spend a ton of time on this. So it's not like a big, huge loss where I had to spend weeks of time training a model to find out it didn't work. Um, I was able to find out fairly quickly, which is nice. Um, there's a lot of other interesting things you can do. Like if it is, if it looks like it's doing things, uh, if it looks like it's extracting parking lots well, if it had, then you could manually tag a bunch of imagery to get it to be more accurate and then have it measure itself and have it iterate on the prompt on its own. So it's like, tweak the prompt and rerun, tweak the prompt and rerun, tweak the prompt and rerun. And you can kind of, you can get it to do quite a bit of work on its own that way. Another question. I've had trouble with Claude hallucinating ArcPy and arcade function more often than it seems with other non-Esri specific code. Have you dealt much with that? Yes, I will say that it has gotten a lot better, and Claude Opus 4.6 is way better at not hallucinating. The thing that will make the biggest difference to help reduce hallucinations is giving it documentation. So, for example, like the Python API has a GitHub repo where you can download the like raw documentation files and you can toss that into your folder. And then you just tell it, hey, you have documentation about the Python API. Or you can say, go and scrape or download a bunch of documentation about ArcPy from the Esri website and build yourself a repository to look up functions that are appropriate and then only use that going forward. So you can say things like that to Claude and have it go and do that. And that's actually, I did that with Experience Builder several weeks ago, where basically we built a custom Experience Builder widget in an hour session like this, and it did work. But I did some prep ahead of that one. And the prep that I did was I'm going to stop sharing since that's not where I'm not going to try to rerun it in the last 2 minutes here. I did some prep to gather documentation about Experience Builder. And you can do the same thing for ArcPy. We have some of that internally that my company's done. And basically what you do is you go into a Claude desktop, like Claude.ai or Claude Desktop or Claude Code, and you say, I want you to gather documentation about ArcPy, the newest version or a specific version if you have a specific one you want to work with. And scrape the internet, search the internet for documentation so that you hallucinate less. and it like understands that as a concept and will go and build its own documentation for that. You could standardize that into what's called a skill in Claude Code, that it can then trigger on its own. But just having the documentation there is often enough to prevent most hallucinations. You can also just have it test it itself in Claude Code. So if it's running the script on its own, it will test itself and it'll find those hallucinations and repair itself. And that kind of loop where it can run it itself, look at the output, run it itself, look at the output, run it itself, look at the output, can actually prevent a lot of those hallucinations because it'll fix all of that before you get there. And the whisper frame behind me did successfully draw a parking lot, so at least it was on the ball today, even though Claude and Gemini were definitely not doing a great job of detecting parking lots. So yeah, any other questions here? I talk about this stuff all the time on LinkedIn, and I have a weekly newsletter where I talk about this stuff all the time. So you can follow me on my website or on LinkedIn and see various other content like this. I might try to get this to work a little bit better and repost it, but yeah. So thanks for watching. I can hang around for a few more minutes if anybody has other questions or other things to talk about, but sorry it didn't work. I guess that is the price of a live demo, is sometimes it just doesn't work. So thank you, everyone.